On previous episodes of Built to Last, we've talked about the interior structure or the bones of a building. Today, we're going to be talking about the building envelope or the muscles, as they're sometimes referred to, and make sure that it's doing what it's designed to do. Now, the building envelope is actually the structure of a building that incorporates all of the building materials and components to create a whole and complete system that maximizes energy efficiency. Now, it's more than just insulation, because a leaky building can cause a lot of headaches, like mold, insects, rodents, even air infiltration, which will cause higher energy costs. Now, a building that's more sound will increase energy efficiency, lower your energy bills, and provide a more comfortable and healthier place to be.
Built to Last is sponsored by Unico Incorporated, manufacturers of the small duct high-velocity HVAC Unico system. Unico is dedicated to the environment and has been serving residential and commercial customers around the corner and around the globe for more than 25 years.
Great Northern Lumber, providing green construction materials from skyscrapers to residential remodel. Proud to serve you for the last 27 years and into the future in the lumber industry.
Behind us is the Healthy Home 2010 project. Now, as you can see, it's a gorgeous custom home under construction, but what's more important is the building envelope, and we're going to find out just what that is from Lorene Blissard. It's great to see you, Lorene.
Nice to meet you.
So what is the building envelope?
Essentially, it's the exterior walls of your home, and they're very important because if your walls of your home let in air or let it out, much like this bag, this is pretty much how conventional homes are built today, it has the potential of bringing in pollutants from the outside as well as letting all your energy escape, which is unfortunate. With this home, there were some things that we did that are special, and as this example might show, we tried to prevent that air infiltration, and parts of the technique would be incorporating our roof and our windows and our doors, as well as other elements that I'd like to show you inside.
Okay, so in having a superior building envelope like this one, why is that so important for a homeowner?
Well, most homes consume about, well, homes in general, I should say, consume about 22% of all the energy consumed in this country. And so anything that we can do on the small level can help in the big picture. So our first stop here is the master bath. And a couple of things I wanted to point out directly overhead were these two vents as well as the light fixture. And the reason why this is important is they penetrate that envelope that we talked about earlier, and because they do, we have to make sure that they're properly insulated and caulked. Otherwise, that air infiltration will come in, and as you know, warm air rises, especially warm, moist air, and what would happen if we didn't do that is we'd condense on this cold metal, and then the homeowner ends up with a shower over the tub that they never originally intended.
You don't want that, right?
No, absolutely not.
Okay, and then these other holes right here, these other vents?
Right, these vents actually go through, or they're actually ductwork from the mechanical systems, go through the attic. And one of the things that, or strategies that we implemented, was making sure that they were insulated, and you can see that pretty much right over here coming out of the mechanical room. And so we won't have that problem where warm, moist air meets with cold metal and then have moisture in the attic as well, so we won't have that problem.
Well, that's great, because this is a pretty large space, so I would, think that there would be a lot of moisture here when people are, bathing and things. So
absolutely,
okay.
Absolutely. And so we obviously want to make sure that we pay attention to that. And some other things that you can do to help with the envelope is make sure you install the proper exhaust fan, because you'd like to get that warm, moist air out as quickly as possible. Otherwise, well, you've seen what happens when when it builds up. You end up with mold and mildew in your bathroom, and that's definitely something that you don't want in a healthy home.
And Lorene, what is special now about this area here? Oh, no, don't touch that. How can you do that? Her face is on there. Oh my gosh. Don't you need gloves and a mask to be touching insulation?
Not this particular kind. This is made out of recycled blue jeans, believe it or not.
You're kidding?
No,
like what we're wearing?
I'm not kidding.
Oh my gosh.
I mean, I would not be doing this if it was fiberglass, trust me.
Oh my gosh. Oh my gosh. That is so cool. So, and this is something that's a new addition to being a healthy home ingredient.
Well, it's a new technological advancement in insulation in the past few years or so, but it's definitely another alternative to doing fiberglass. But what's really more important is when you're installing any kind of insulation that's in contact with the air barrier, and in this example of this home, we're using plastic, and so that helps prevent this air infiltration from bringing in those unhealthy pollutants, as well as letting your energy conditioned hot or cold air leaking out of the wall.
Right.
And other techniques here in this corner that I can point out, we've caulked the corners and foamed the gaps of all of our windows as well. And the thing I do want to point out about this, though, is once this is all drywalled, you can't change it. I mean, you could, but not at considerable expense. So when you have the opportunity to put in the right insulation or the right air barrier and to caulk all the gaps and cracks, now's the time to do it, because you're not going to have an easy time doing it later.
Because it gets really costly if you need to get back in there later.
Well, absolutely,
Right,
absolutely.
Right. Lorene, thanks a lot for the tour of the building envelope, but I wanted to ask you before we're done with this section, is there any way that you can build a home possibly too tight?
Yes, there is.
Okay.
And, you know, the saying is build tight, insulate right, but make sure you've got enough air changes, because, you know, coupled with the materials that you select, you have the potential of creating an unhealthy home. So making sure you select the right materials and making sure that you have, and in this home we actually have what's called an ERV. It's an energy recovery ventilator. So what's happening is that our conditioned air is going through this unit and the energy is being transferred to the fresh air that comes in. So we're not wasting energy,
Okay.
but we're also making sure that the air continues to be healthy, because ultimately it boils down to having a healthy home.
Excellent. Thank you so much.
It's a pleasure.
Today, new buildings are constructed with energy savings in mind, but that doesn't mean that an existing home can't be upgraded to improve its energy efficiency. A certified energy analyst will come in and perform a comprehensive energy diagnosis using a variety of tests to find out where the problems lie. Once that's done, they'll make suggestions on what measures need to be taken to improve your energy efficiency, so you as the homeowner can make those corrections with confidence.
Basically what we do is we provide our clients with a reasonable action plan for air tightening their home and making their home more energy efficient and comfortable. In the end, it's going to improve the value of the home and be a more durable product. A CEA, or a certified energy analyst, is going to come in with a series of equipment and perform a number of tests to the home, and then based on what they found in the home, provide recommendations to the homeowner so that they can then contact skilled tradespeople to fix the problems. They can do their energy improvements. Some of the pieces of that process are that we're looking for air leakage with a blower door test. We're using an infrared scanner often, if we can, to check for insulation in walls. And we're looking at the heating and cooling equipment, if it's the correct type, if it's safe. For example, we'll usually do a combustion safety test of that heating equipment, meaning the water heater and the furnace. We'll also look at the distribution system for the heating and cooling system, which is typically ducts, but it sometimes can be a radiator system or pipes. And we'll also ask the homeowner about their utility bills. We'd like to look at the utility bills, and that's also a way they can compare before and after they've done their energy improvements. The blower door, which is probably the most important test that we do as energy raters in a home, is basically composed of a framework with a fabric that is air resistant. And inside of that fabric is a hole where we place a calibrated fan. The calibrated fan is then hooked up to a pressure gauge and a flow gauge, which allows us to measure the flow rate going through that fan, and also enables us to see how much pressure we're getting. Because basically what we're doing is the fan is pulling air from inside the house, pulling it to the outside. In the process, it's called depressurization. So we're depressurizing the house. And one of the reasons we do that is to find air leaks in the house, because air leaks are kind of the little known secret that people don't really understand much about air leaks in homes. They understand insulation, they understand windows might leak and doors might leak, but they don't understand that there's some more complex places that there may be air leakage in the home that they are really important to seal. So the blower door test points us in that direction. We can use a blower door in conjunction with a smoke wand or smoke puffer, or in conjunction with an IR camera. Either one will work, and it shows us where the air leaks are. The other thing the blower door does is it gives us an absolute measurement for how leaky that home is. And we can compare a home in Chicago to a home in Miami or a home in London using these measurements, and they're comparable. You know, you can absolutely, you know, compare across homes and say how leaky a house is. We've got some typical old single pane metal frame windows in this basement that are quite leaky. There's quite a bit of air infiltration in here, and in the winter you have more pressure building up in the bottom of the home, and the air tries to come in the bottom, so this is an especially important part to seal. Pete, what would you do with a situation like this?
Cheryl, I think when you see an old window like this window's an R1 steel frame single pane window. Times have changed, and we now have R5 windows with more advanced framing systems, fiberglass or vinyl. I think it's time that this young family upgrades their windows.
I agree. They can get the benefits of an airtight window and a better insulated window. It'll both airtight in this basement, and it'll help to improve the overall efficiency of the entire house.
Cheryl, these windows don't even have screens, so they can't even really open these windows and not have the bugs get in. Let's get them a new window, have some screens. It'll reduce their utility bills if they change out the windows in this house probably by 30% by going to an R5 window. That's a young family, and they could probably use a few extra dollars every month. I think we could save them a lot of money.
That's a good point. The usability of the newer windows is a great point, because no one ever opens these ones. They get rusted and shut, and they just stay that way because there's no screen. So get them a window that they can actually use. It's a great idea.
Absolutely. I think you know what you need to do.
Okay. This house has a significant leak between the rim joist and the sill plate, as you can see right here. And an even bigger leak is happening between the entry slab and the floor. Air is really pouring in, and it needs to get sealed up to improve the energy efficiency of the home. What would you recommend we do here to solve this problem?
Well, Cheryl, we do obviously have a problem here, and we've got air infiltration, air leakage, and we've also got insect infestation in this example. The proper way to address this problem is to use a 2-pound closed-cell spray foam that serves multiple purposes. One, it will seal up the area from an air infiltration perspective, and number two, it will provide some insulation value, which will help reduce overall heating and cooling costs for the homeowner.
That's right.
Yeah.
And this particular part of the house is very important to air seal and insulate. People aren't aware of it, but there's more pressure from cold, dense air in winter at this part of the house than there is in almost any other. So by sealing up this part, you're doing a great deal to improve the tightness of the home overall.
Absolutely. Tests have shown that approximately 30% of the heat that is lost or gained in a home comes from this rim joist area. It is a very leaky part of the home. Again, if we do close this up with a closed-cell foam, seal it, and insulate it properly, we will definitely have a payback for the young homeowners that are here.
Yeah, this will be a really tight house when they do this and a couple other things in the house.
Absolutely.
Yep. I'm here in the attic with Mike Milken of Milken Insulation, and we've got a very leaky attic floor. There's a number of penetrations through here, the flue stack, the soffits, the plumbing, the light fixtures. All these are areas where warm air, which has been heated and conditioned in the first floor, can migrate up and be lost to outdoors. What happens in winter is the cold air is pressurized at the bottom, comes in the bottom, and then it warms up and goes out the top of the home. It's a little bit like a straw. If you pinch the top of the straw, being the attic, and you pinch the bottom of the straw, being the basement, you've air sealed your home. And then you can proceed to insulate. Now, how would you what would you tell the homeowners to do here?
Well, Cheryl, that's a great analogy, and indeed that's what's happening in this home. We've got probably the most obvious condition here, a huge opening around this furnace flue, tremendous air infiltration, and an avenue of escape from the home. The chase here, you can see the smoke is just diving down. So the reverse happens in the wintertime. That's warm air just running out of the house. This has to be sealed with either a sheet metal or drywall enclosure, caulked so that it's airtight. Stop that heat loss. The same thing with the soffit. It's wide open. The smoke is just diving out of the attic. It's being sucked out of here. The reverse is happening in the wintertime. The heated air is just racing out of the house. So we've got to seal this off. You got to get, you know, a skilled carpenter tradesman in here and block it with insulation, and then seal the top of it and stop that heat loss. This is the most obvious condition. It jumps out at you, but all over the house there's openings that for the electric fixtures, the lights, there's soffits in the bathroom back there. All of that has to be closed and sealed, and then when we've energy sealed the attic, stop the air infiltration, then we can add more insulation and bring it up to the R49 standard that in this climate zone is required. Right. So there's a lot of work to do up here.
Yeah, and a lot of people don't realize that it's really important to air seal before you insulate.
Absolutely. We don't add insulation to attics unless we've air sealed prior.
That's so important, because you can really get into trouble if you don't do that.
Well, you're not getting the benefit out of the insulation if you're going to add insulation and then allow air to travel through it.
That's right.
You're just not going to get the right benefit.
Right. Well, hi, Tom. We've got some windows here in this house that are pretty old and they're in bad shape. They are leaking around the sides and at the bottom and also at the meeting rail. We've also noticed that there's some cracked glass in these single pane windows and missing glazing putty. In addition to this, the homeowners are interested in getting a window that will perform better as far as sound, as a sound barrier, because they have a train right in their backyard basically, and it comes through very regularly, and they would really appreciate having a better sound barrier in this location. So what would you recommend?
Well, Cheryl, what you got here is your standard single glazed window with storm windows. For the sound transmission, I would recommend replacing with a triple thermal pane window, which would help prevent some of the sound coming in from the exterior to the interior. As for the performance issues you bring up, some of the older windows rely on a friction fit within the frame and from the sash at the meeting rail. And in some cases, they don't even have weather stripping between the two sashes. The window installation is actually very important. A window is only as good as the installation. If you don't have proper sash to frame alignment, you will have issues later down the road.
Once you found these leak points in the home, then you want to go back around and figure out what product is appropriate for each leak point, because in some cases it will be spray foam. In other cases where there's need for fire-resistant material, you're going to have to use drywall or metal. And then once you've finished air sealing all these locations with spray foam or metal or fiberglass or rigid foam board, then you're going to want to insulate the walls in the attic. In this case, it's the attic. So they're going to want to add about R49 of insulation in this attic.
Well, all the work has been done on this home, so Cheryl is back to give me a tour. So Cheryl, what's new here?
Yeah, well, the homeowners here have a train that they're living next to, and it's very noisy inside this first floor. So they've replaced a single pane window with new dual glazed vinyl frame window.
Okay.
So they're very happy. It's reduced the noise of the train. In addition to that, they now have low-E coating in the glazing. The low-E coating is a metallic membrane, basically, or filter that reflects the sun's rays and the heat in the summer, and it traps the heat in the winter.
So in the summer, the home stays cooler. In the winter, the home stays warmer, right?
Right.
Okay, that's a good thing.
Okay. And the other thing that's different about these windows is the installation. The installation before was not very good. There was air leakage in what we call the rough opening between the window and the door. And in fact, this was what was being used to air seal that rough opening, and that is not an air seal.
That's a good one.
That's not an air seal.
Okay.
So now we have had skilled, qualified carpenters to install these and air seal this rough opening.
Okay.
The tightness of the overall envelope is very important. So this is just one piece of a larger puzzle. We're trying to tighten the home envelope throughout this home.
Okay, so have you replaced windows in other parts of the home then?
Yes, we have.
Okay.
Why don't I show you some in the basement?
Okay, let's go.
Okay. Well, Jana, now we're in the basement, and we're going to be replacing this old, about 1950, single pane metal frame window.
Wow.
Which has really served its purpose. It's time to move on from this. And we're going to be installing this nice new dual glazed low E window, which will check and see if it really has the low E coating on the glazing. Yes, it does.
Excellent.
It has the metallic coating.
And this window will help the homeowner's house, Cheryl.
Well, basically, we're going to go from an R1, which is minimal R value, to an R3. So we're going to increase the R value by 3 times, and it's going to stop the air leakage. This was very leaky, and by installing this correctly, we won't have any air leakage coming in.
I bet that's going to help with sound too.
And it'll also help with the sound.
Yeah, excellent.
That's right.
And then Cheryl, I see all this yellowy stuff up here. What's that?
That is a closed cell spray insulation. It's an excellent air barrier. We had a very leaky rim joist, and now we're not going to be having the air penetrating this boundary and have the leakage problems that we had before, which will keep a tighter home and a much more warm and comfortable home in the winter.
I hear that you did some work up in the attic too, right?
Yes, we did.
Okay, let's go take a look at that.
Okay.
Woo, Cheryl, it's a little hot up here in the attic.
Yes.
Is that a good thing or a bad thing here?
In this case, it's a good thing.
Okay.
Because if we had air conditioning down below and we had lots of leaks through this attic floor, it would mean we'd be cooled by the air conditioning, but we're not.
Okay. Well, what are some of the things that you've done up here?
Some of the things we've done is we've put the same spray foam product that we used down in the basement here in the attic floor right by the kitchen soffit. So we've gone down below the joist and we've spray foamed to cover the opening there, and also where there's an exhaust fan, there was an opening around the exhaust fan. So we sprayed those and air sealed them so they're nice and tight. It's like pinching the top of the straw.
Oh, very good. Okay. And then Cheryl, what is this gray material back here?
Well, that is blown-in cellulose, and it's just an excellent product for insulating attic floors.
Okay.
It's environmentally friendly, it's inexpensive, and it's got an R value of about 3.5 per inch. So you put an amount that's necessary for your climate, and you're good to go.
Wow, the whole package it has then. Okay. Thank you so much for some great information on how we can all tighten up our homes. Thanks.
You're welcome.
I'm really passionate about energy efficiency because you can essentially help the environment, save energy, and save money all at the same time. And you may wonder, why is saving energy or lowering my electric bill going to help the environment? And here's why. The connection is that in the US, and especially in the Midwest, most of our electricity comes from fossil fuel power plants. The problem with fossil fuels is, first of all, we only have so much of them, so they're going to run out one day, so we should conserve what we can. And second of all, most importantly, when we burn fossil fuels to create the electricity we use every day for lighting, for our TVs, for our video games, that electricity is being created in this power plant, which is actually spewing pollution into the air. So that's a connection I think a lot of people actually we don't make. We forget about it. We're so used to having a nice warm house in the winter with all these wonderful, luxuries like appliances and lighting and all sorts of things, which are fantastic. But to really look deeply into how do we get that power? And a lot of times it does come from fossil fuel power plants.
Having a tight building envelope is not only great for the environment, but it also helps you, the homeowner, save money too. Thanks for watching Built to Last. I'm Jana Peterson, and I'll see you next time.
Visit the Built to Last website to learn about these topics and more.
Built to Last is sponsored by Unico Incorporated, manufacturers of the small duct high-velocity HVAC Unico system. Unico is dedicated to the environment and has been serving residential and commercial customers around the corner and around the globe for more than 25 years.
Great Northern Lumber, providing green construction materials from skyscrapers to residential remodel. Proud to serve you for the last 27 years and into the future in the lumber industry.